Lesson 9.6, Analyzing Functions with Successive Differences. In this video, you will learn to identify linear, quadratic, and exponential functions from given data, as well as write equations that model data. Okay, so in order to do this, we want to be able to look at the different types of functions. So we've looked at linear, and we've looked at exponential, and now we're going to start looking at quadratic a little bit more. So we want to be able to look at data either in a graph or in a table and say which model would best fit the data, whether it's linear, quadratic, or exponential. So let's start by doing graphing. And so this is basically just graphing the points and seeing what it looks like. So I start by graphing the point 1, 2, then the point 2, 5, the point 3, 6, 4, 5, and 5, 2. And when I do this, it looks like a parabola. It forms this U shape. So because it forms this shape, we're going to say that this is a quadratic equation or function. Okay? So if we were to graph these ones, let's do the same thing. I graph -1, 6, 0, 2, 1, 2/3, and 2, 2/9. I get this, and this looks to form one of those shapy thingies like that. So that is an exponential. Okay, so it should be pretty easy by looking at the graph to determine if it's quadratic, exponential, or linear. And of course, we didn't look at a linear example, but a linear would just be like a line. Okay? So we want to be able to look at the data. So first thing we always want to check is to see that the x's are changing at a constant rate. And here they're increasing by 1 each time, so that's okay. And then I want to look and I want to see how much the y's are increasing or decreasing by. So here I'm adding 2 each time. So because I'm adding the same number each time for when the x is increasing at the constant rate, we learned earlier that that is linear. So this is a linear function. Okay, I'm going to look at this one. And what am I doing each time? I'm going to look at my differences. So 36 minus 12 is, 36 minus 12 is 24. 12 minus 4 is 8. 4 minus 1.3333 is 2.2 2/3. Okay, and from 4 1/3, or sorry, 1 1/3, so 1.333 minus 4 9ths, I get 0.888, or 8/9. So looking at these, I want to see if something's going to be quadratic after you found the first differences. The difference is how much it's increasing or decreasing by. If it's the same difference between each of these now, so between these it was 24, 8, 2 2/3, and 8/9. But if I go between 8 and 24, I want to see if these are the same for the next level. If they are, it's quadratic. If they're not, then we want to check and see if maybe it's exponential. So 24 minus 8, I get 16. And then 8 minus 2/3, that's not going to be 16. So this is not quadratic, and it's not linear. Okay, so we want to see if this is exponential. And if you remember from previous sections, exponential increases by the same rate every time. So if I go, so if I do this one over this one, so 4/9 divided by 4/3, I want to see if that's the same ratio as all the other ones. So 4/9 times 3 over 4. Those 4's cancel and I get 1/3. Okay, so I want to see if this is the same. So 4 over 3 divided by 4. So that's 4 over 3 times 1/4. So I get 1/3 again. 4 divided by 12 reduces to 1/3. And 12 over 36 is also 1/3. So each time you can multiply each of these by 1/3 to get the next number. So that makes it exponential. Okay, so the idea is second layer, if they're the same when you find the differences, that's quadratic. If the first layer is the same, that's linear. And if it's a constant ratio that you're multiplying each time, that's exponential. So we want to look at this. And right, the first thing I want to check, because I can see it's not increasing at a constant rate, it's easier to check a ratio before the quadratic. So let's see if this can be multiplied by the same number. And it can. This is times 8, times 8, times 8, times 8. So because you can multiply each of these by the same number, that's going to be exponential. Okay? At the beginning of this, in the chart and on your note-taking guide, there was equations that went with each of the types of graphs. So for exponential, it's y equals a b to the x. So I want to use this information here to figure out what my a and b are. So I'm going to start by taking a point. It's easiest if there's a 0. Those ones are easy to figure out. So if I use that point there and I plug it in for x and y, I can solve for my variables a and b, which is my goal. I want to find a and b. So I put in -1 for y, a and b I don't know, and I put in 0 for x. But anything to the power of 0 is 1, so I get -1 equals a times 1. So a is just going to be -1. Now I know a, and I need to find b. So I'm going to pick another point, so I'm going to use this one, and I want to plug that in. Y equals ab to the x. Except now I already know what a is, so I'm also going to put in a. A equals -1. So I'm going to say y was -8, a is -1. I still don't know b, I want to figure it out, and I know x is 1 from up here. So b to the first is just b, so I get -8 equals -b, -1 times b, and so then b is going to be +8. So now that I know my a is -1 and my b is 8, I'm just rewriting my equation y equals a b to the x with a and b. So it's going to be y equals -1 times 8 to the x, or you can just write that as -8 to the x, like that. Okay? If I want to write an equation for a real-world situation, such as this one, first thing I need to do is figure out what model to use, exponential, linear, or quadratic. So I look at the differences. From 8 to 11, that goes up by 3. 11 to 14, that also goes by 3. 3 and 3, they each go up by 3. So if you're increasing at a constant rate, that means that it's linear. And the form of a linear equation is y equals mx plus b. So remember, slope m is change in y over change in x. So if we're looking here, each of the y's, if we're thinking of this as x and this is y, the y's are changing by 3 and the x's are changing by 1, which means my slope, my m, is going to be 3 over 1. So I can put in 3 over 1 for my m, or just 3. And I still need to figure out what x and b, basically I need to figure out what b is. So how can I find b? B is the y-intercept. The y-intercept occurs when x is 0. So if I look and see what x is 0, that's at 8. So I can say that 8 is my y-intercept. If I didn't have 0 in the table there, what I could do is plug in any point, any of the points that are there. So let's say over here I had y equals 3x plus b, and I didn't have this point here. I can choose, say, this one and solve for b. So I'm just putting in the point x and y, so I know y is 14. 3, I put in 2 for x plus b, and I get 6 plus b equals 14. I subtract 6 from both sides, and I get B is 8. So you can figure out 8, you can figure out your B that way too. But if you have the 0, it's just easiest just to take it and plug it in. Okay, and that is the end of this section. And we'll go over any more questions you have in class.